reminisce. They molt and become very flattened, and then they come back to the fish again, feed again, they get all fat again, then they leave, go down to the bottom, molt, come back thin, get all fat again, then they finally turn into adults. Then they reproduce and produce a young stage, which starts the cycle all over again. Some of you, if you've been looking at a lot of shore crabs, you'll have found some which have got things which are not eggs underneath them in the pouches that the males and females have below. And they are parasites, barnacle parasites. This is a young stage of one. You can tell it's a barnacle by the horns on the front. It's also got this one has got a strange thing like a fish scale in its back. I don't really know what it's for. It's called a flotation collar in the literature, but it looks the last thing it would need on its back to help it float. It looks like an impediment to swimming. And this goes through several molts, and then it goes into a stage called a kentragron, which injects itself into the crab through plates between the shells, the joints between the shells. And then this kentragron stage goes through the crab like a fungus, and it changes the hormones in the crab and turns it into a bit of a zombie crab. And then this big sac emerges from the pouch on the bottom of the crab, and it's the female of the parasitic barnacle. And there's a small male attached to it, which fertilizes the eggs, and all these little cirripede nuclei emerge from it. So, and you would never know it was a parasite, but just a big blob. But many parasites are like that. Then we'll go on to this copepod here. It's a parasitic copepod, commonly called things like fish lice, because they're really common in fish farms feeding on salmon. They're a real problem because they feed in the mucus on the surface. They hang on to the salmon. They can cause a disease, lit disease in. They damage the surface. They make the fish unsaleable. They spend millions of pounds a year trying to treat them with chemicals. And they had until recently, I don't think they're doing it now. They were catching wrasse down here in the southwest and sending them up to fish farms in Scotland where they were using them as cleaner fish, because wrasse are cleaner fish. They'll go up to fish and bite off the parasites that are attached to their bodies. Another interesting copepod is this monsteroid copepod. They're a parasite of tube worms and gastropods on the bottom. And they spend all their life inside the gastropods and the tube worms, and they emerge as adults, and the adults are only there for reproduction. They can't feed. They're very beautiful animals. This is a female. It's carrying all its eggs on this long stalk behind it. Normally in a copepod, you'd have a lot of feeding limbs coming out from the front, but there are none on this. They can't feed. They just reproduce and die. Other parasites you see in the plankton in shore are flatworm, cercaria larvae. You can see it's a trematode flatworm. You can see a sucker there and a sucker at the front. It's got a couple of little eye spots. And these swim, they're fish parasites, and they're in feces from the fish. And the larvae will swim. They'll probably go into a mollusk of some sort first. Then they develop, and then they come out from the mollusks, cercaria larvae. They'll swim to something like this jellyfish here and attach to it and lose their Christmas tree tail. And this one has got over 100 parasites on it. So you just imagine a fish comes along and eats this, what a parasitic load it's going to get in one quick meal. Another common parasite you get in can get in the plankton are nematodes. They're one of the largest phylum of organisms. There are thousands of species of nematodes, but to me they all look the same. But you occasionally find them inside things like arrowworms. There's one there. There's a young one inside that one. Here's one inside a copepod. And they are eaten by fish, and you get them. They can migrate into the liver, or they can migrate into the flesh. And there used to be people employed in fish houses when fish were being filleted, to remove these nematodes with tweezers, because they don't look very attractive in your fillets. They are parasites of seals, and there are stomach parasites of seals. They come out in the feces, and the young stages are eaten by things like krill or copepods. Then the copepod or krill are eaten by a fish, and that infects the fish. then it goes back to the seal, which then gets the parasite again. So that's the cycle completed. But if we eat the fish without either cooking it or freezing it, you can get a disease called anisakaisis, and you'll get that if you eat sashimi, like they do in Japan, or ceviche in South America, or fermented herring livers, corned livers around the Netherlands or into Norway. And Japan reports over 1,000 cases a year of this parasite in humans. And what it does, it tries to bore through the gut wall, but it's not adapted for humans. And all it does is cause an allergenic reaction, or an anaphylactic sort of reaction, and the gut swells up and closes up and blocks. So they've got to sort that out. And it can be sorted out, but it still is quite a problem in some areas of the world. I'm just going to speak a little bit about biodiversity. I mean, Plymouth Sound is a fantastically biodiverse place. This is the estuary from the Plym coming down here. You've got offshoots like Who Lake, up into Sutton Harbour, Millbay Docks, up into Stonehouse, and up through to Millbrook Lake, St John's Lake, up the Tamar, and all the sound out here behind the breakwater. It's all different depths, different bottoms, some muddy, some stony, shallow. There's tides coming out, in and out, fresh water, nutrients coming down from farms, all sorts. Very productive, terrific number of habitats. So you get very good biodiversity. I'll get it finally. And we know a lot about what is locally, because over many years, people recorded what they'd found all around the area, including Plymouth Sound and further out. And there are it's called the Plymouth Marine Fauna. It was recorded last published in 1952, I think. So it's a bit out of date, and a lot of things have been found since then. But it's a tremendous source of information, because it tells you information about where things were found, which month, if they were reproducing. Really good. If you wanted to go and find a particular thing, you could also go back to where it was found and try there. But things like this are a terrific source of information. And there's probably about 3,500 species have been recorded locally, and many of these have got planktonic stages. So it gives us a terrific biodiversity locally here. And in fact, we get most of the European plankton species at Plymouth, because we also get oceanic species coming in from the open sea. And we do sample off Plymouth here. We have a station called L4. I can't remember why it's called L4. We've also got a station L5 and an E1. And Plymouth Marine Laboratory also samples here every week. So we've built up a lot of information, especially Plymouth Marine Laboratory they've been sampling there for about 25 years now. So they have a lot of information about all the species that are there. But MBA also has a lot of information here as well. And we get a lot of oceanic species coming in certain times. There's some very beautiful ones. This is a siphonophore called Nugia atlantica, related to the Portuguese man-o'-war, but a completely different sort of species. Very beautiful. Solmaris corona, it's an oceanic jellyfish. Very, very beautiful one too, with a central, they call it corona, I suppose, by the sort of appearance of a sun in the middle. These two are actually related to us in their larval stages. They have got a primitive noted cord equivalent to our sort of backbone, or sorry, the nerve cord we have in our backbone. This is a pelagic sea squirt. You're familiar with sea squirts that you find around marinas, etc. It passes water in one side and out the other, and filters out all the plankton in these gills here, and then it grinds it down in the guts here. Oceanic jellyfish, Liriope, a big more oceanic copepod called Subucalenus crassus, which I find reproducing here, and the eggs, interesting eggs. It's got a small central part and a large gelatinous part on the outside. And this is the early nauplius stage, and another copepod called Tema sterifera. Now these we get these at particular times of year, but just by sort of looking at the samples locally, some of these appear to be spending longer here, longer parts of the year here. And it may be because of global warming, but this is just sort of anecdotal information. I don't sample things quantitatively. Most of the work I'm doing is just for photography and out of interest. But eventually, with global warming, some of these species, we could get them here almost all year round at Plymouth. But we know that our planet is warming up because of our use of oil and release of carbon dioxide. And this, of course, because of the warming temperatures, plankton distribution are changing. Now, we can't really monitor or measure that by taking one sample every week off Plymouth, just one spot. It doesn't tell us anything over a large area. And it's difficult to do that using a research boat, because many of these larger boats are going to cost about £30,000 a day, and they can only cover small areas. And what you want to do, if you want to find out about animals, how they're redistributing themselves, you need to go and look at massive areas. And there's a group of people in the laboratory and the MBA called the Continuous Plankton Recorder group, who use a piece of instrument called the Continuous Plankton Recorder. And this was a survey which was started in 1931 and is still going strong. It has been expanded a lot. And what they do is they tow this instrument behind ships. And they are ships which are going about their routes regularly. And these are ferries and big container ships, cargo ships. And they have routes going off from all around Britain. We've got several going across the North Sea to Norway, to Denmark. We've got them across to Roscoff in the Roscoff ferry. They go down towards Spain, into the Atlantic, up to Iceland, from Iceland across to Norway, across the Atlantic to the coasts of Canada and the US. And we're even getting routes now up into where there used to be ice all the year round towards the north of Canada. We're getting them up there now too, as the ice has been retreating. And this allows us very cheaply to cover very large areas and to get information that we can use to create maps of the distribution of plankton. And this is how it works. The instrument is driven by a propeller. This is the mechanism inside. So the faster the ship goes, the faster the propeller goes, faster the mechanism goes. Plankton comes in through the entrance here, down this channel. There are two rolls of gauze, top and bottom. They're like toilet rolls. And the bottom one unrolls, and it goes over the water which is coming in through this channel. So the plankton is filtered onto the gauze. And then the roller carries on pulling it in, and it joins the roll from the top. So it forms a sandwich of plankton, which then goes on to the third roller inside in a tank of formaldehyde. So what you end up with is a long sandwich of plankton along this great long roll of gauze. And we know where the plankton sample was taken by the ship's log, and we can cut it up into 10-mile lengths and assign it to a particular position on the globe, wherever it was taken. And we look at these under the microscope, actually on the mesh. This is how we look at it. You can see bits of things on the surface here, and we count them and record them, and then they are computerized, and then we build up maps of all the distribution. That's how we do it. Another thing that you can actually pick up on the Plankton Recorder survey are alien species. We've got hundreds of species around the UK which have come from abroad in ballast water, which I'm sure you know about. The water which is taken into ships when it goes into harbour. When it takes the cargo off, the ship of course rises up in the water, and it's unstable and it can't sail like that. So it takes in water from the harbour into big tanks aboard, and of course it takes in loads of plankton too at the same time. And then it will sail perhaps to the other side of the world, and before it takes on a cargo, it will unload all this water from its tanks, and of course it's depositing all these species it's taken from a harbour in one place to a harbour in another side of the world. So these have been spread around like this for many years. There are a lot of regulations now to stop this, but of course it's a bit late for that now, but for many of the species that have been spread. And these are some of the species that we get here. Acacia margalefi is a species from Spain. It was first found at Southampton, but we get it in Millbay Docks in Plymouth that I just showed you the picture of there. And which is coincidental. There's a Spanish ferry comes into both Southampton and to here. But it has spread around a few other places too, Panilla averostris is a water flea. It was first found in the Continuous Plankton Recorder survey in the southern North Sea. And it was never found in the Channel, but I found some off Plymouth about 3 years ago. And then it came again the next year. And so it seems to be spreading around too. It is found along the French coast down towards Spain, but it was never in the Channel. But it could be happening now too. Eurytemera americana is quite an interesting one. It was found at Plymouth in 1931 and was never found since. It was found out in the Sound, in Plymouth Sound. But I found it a couple of years ago and I was quite surprised. Where's it been hiding? Why has it appeared all of a sudden? And just by chance, I took a plankton sample up the Plym estuary, and I found hundreds of them there. And I'd never sampled up there before. So possibly they've been hiding up there all the time. And just now and again, some gets washed out and end up in the Sound and you sample them. So that would explain that. But that explains why it's sometimes difficult to sample these alien species, because they turn up sporadically, they're hiding away in odd corners, and they can be very seasonal. And people are not sampling all around the UK, they're just sampling a few spots. And that's happened across. So there are probably far more alien species spread around about and than we realise, and far wider spread. And we don't know really what effects some of these species have on the local populations. You get some obvious ones like some of these ctenophores, the comb jellyfish, were Americans were introduced into the Black Sea a few years ago, and these bloomed in great numbers and fed upon all the local larval fish and caused a crash in things like sardine fisheries in northern Turkey and places like that. But a lot of these things, you just don't know what sort of difference they're making. Another one, this Pseudodaptis marinus, it's spreading all around Europe just now. And we get that in the southern North Sea. We get it off the terrace cafe in Plymouth in front of the laboratory. What's the connection between plankton and the petrol station? I think as you all know that the fuels, the oils that we dig up, we pump out of the ground comes from a lot of plankton and phytoplankton, which died over millions of years, sank to the seabed, and all the oils contained went into the rocks, etc. But we've used it, of course, for fuel. We've used it for bitumen for the road, synthetic tires, plastics, all the gutterings here, downpipes, etc. It's an amazing material, but we are running into many problems with plastics now. So we've really got to curtail our usage of them and of fuels. And this is just some of the things that you could make from medicines, fertilizers, anesthetics, even all the COVID testing. I'm being topical here, all the COVID testing kits. So we owe a lot to plankton, and they're amazing materials. We'll continue to need them, but we're going to have to do something about their use of them. And that's me finished. Thank you very much.
Thank you, Dave. That was absolutely mesmerizing, as usual. Yes, thank you very much. It was intriguing. We have a couple of comments in the chat function. Actually, where are we? Yes, okay. So Keith Hiscox has come back on your comment about what L4 stands for. So Keith was saying the L is for local. Further offshore, the E is European or Europe.
Thanks, Keith. I did know at one time. I'd forgotten.
Yeah.
I sample a lot at the Terrace Cafe, so I should call that TC1 for my sampling.
Yeah, Dave, we have a question from Elizabeth here. I would love to take plankton samples from the shore. Any advice on how to do this on a budget too? Is it worth doing from the shore? Well, it certainly is doing from the shore, but I'm sure you can explain better than me.
It is. Actually, the easiest place to get it is somewhere like a marina where you can get really close to the water. If you sort of wade into the water on a beach with a little collecting device of some sort, like a little net, you always get it full of sand. It's really difficult. So it's far better if you can just tow it along a marina or in a harbour or off the side of a boat, a little boat or something like that. But beaches are quite difficult to get a nice sample unless you go quite deep and just sample at the surface. But if there's any wave action, you really just get a lot of sand. But it's relatively easy to make a net. You can buy a few reasonably cheap online, quite simple ones. But people suggest making them from old tights, and it can be done. I'm quite fortunate in having a few more professional ones to catch my stuff. But I get most of my stuff from marinas. But you also got an amazing selection of stuff from marinas, but you got all the bottom living stages of animals. All the meroplankton stages, the early stages of all the bottom living species, and also the regular holoplankton species coming in. So great variety. It's a really good place, marina, to look for samples.
Yeah, we have a comment from Toby, but can I go on before we go on to that? Can I just ask something, Dave? In terms of your sampling, are you finding more kind of nanoplastics in plankton? I'm thinking copepods tend to attract them, don't they? Are you finding more plastic in the samples that you're finding? I know in the CPR recorder they are now monitoring marine plastics, aren't they, on the oceanic tows?
That's right. We do we count plastics in the CPR, the Continuous Plankton Recorder survey, and they start sampling quite far offshore, because when they put the equipment out, it goes down to about 25 meters. So they don't deploy the equipment quite far offshore. Now I sample inshore, harbors, very much in the coastal area. So in some places I get lots of bits of plastic. Other places I don't get very much at all, but usually I get some around the coast. It's just everywhere. And so.
Sure. Okay. Actually, we'll come back to Toby in a second. So, sorry, just come on to this. Yes, sorry. So from Neil and Manda, it is difficult to assess the scale for your images. What sort of microscope power do you need? I think it depends on the species you're looking at, doesn't it, Dave? But again, you can explain that better.
Yeah, I've got a few microscopes. For all the phytoplankton, I have a compound microscope, and I'm probably looking about 80-100 times magnification for some of them, but I've also got lower power magnification. I'm only maybe 40 times, 30 times. Relatively low power, you can look at the zooplankton. It's just what you can afford. But microscopes are not all that expensive nowadays. If you don't mind spending, £200 or £300, which, well, it's a bit, but even for a new one. But you could have perhaps second-hand one. But there are quite a few electronic ones, digital ones now, that you can get, quite simple ones for £20, £25. They can connect up to your computer and then hold them over samples and look at them. It's a wonderful thing to be able to do if you can get a microscope to use. I mean, as I said, after 58 years looking at this stuff, I still really enjoy looking at it. You just never know what's going to turn up. It's like buried treasure.
That's a great description. Yeah, as I say, having done it myself, it's just so exciting. You just don't know what you're going to see, do you? So just going back, Toby made a comment here. Yeah, Toby, do you want to unmute and ask Dave?
Yeah, I do actually.
Yeah.
First of all, Dave, I thought it was an absolutely fantastic talk. Really, really interesting. And I kicked myself because for some reason I didn't hit the recording button until you're at least halfway through. So I'm not. I don't know. We'll just have to put up half of your talk, and I suppose it's a lesson to everyone to attend the talks rather than wait for them to go on YouTube. But I did have a thought as you were talking about the origin of life, and I guess, you know, we always think of the origin of life emanating from the sea. So I'm seeing all your pictures, I'm thinking, well, maybe life started as plankton, and then maybe the phytoplankton, I mean, and then the zooplankton came along, and then from the zooplankton, things started to sort of burrow into the sand, and then sort of crawl out onto land. Is that a scenario that people talk about?
I can't really remember what the present thinking is for that. I think it's quite complicated. I think things branched off in all sorts of directions. I'm not sure about that, Toby.
Okay.
But no, I think you need a better source than me to explain the origins of life.
Yeah. Okay.
Okay. Well, we've just gone 8:45. Has anybody got anything they would like to ask Dave? They can unmute if they want and have a chat with him. We've got a few minutes left. Anybody's got anything burning to ask Dave? No? See, there was something I was going to ask you. Oh, Dave, can I ask you something actually? For various reasons, I'm researching a lot at the moment sea lice on salmon, and the copepods, aren't they? The main species are groups of copepods. Yeah, do you know much about them? Have you studied sea lice particularly?
We do get them the samples, especially inshore. You get loads in marinas. Well, not loads. You get them there. We've got quite a few species at Plymouth. There's probably 20 or so. I can't remember. I'd have to check in the marine fauna. But there's quite a species of caligoid copepods, parasitic, and all different species. Some are very specific to particular species. I get them in inshore. You get loads of parasites in marinas and very close inshore because it's shallow, everything's close together, so it's easy to jump between hosts. So it's a great place to look for them. And I catch quite a lot of sea lice larvae and occasional sea lice too in the marinas. And I identify some of the sea lice, the earlier stages are a bit more difficult to identify because it's based on pigment, and unless you look at them fresh, they're really difficult to. I was trying to help some people up at the Oban laboratory currently identify some sea lice larvae up there, but because all the pigment gets bleached out and preservative, it's just virtually impossible to identify them. They're so similar, some of the stages. Sure. The adults are okay. The adults are okay. Just the earlier stages.
Yeah.
So.
Okay. Thanks for that. Actually, I might email you at some point. Actually.
Yeah, sure. Do that. Yeah.
On that. Yeah, I'd be interested. Yeah. I mean, there's probably a few questions I'd like to ask you about sea lice actually, but I mean, probably outside of this talk. Yeah, I'll email you at some point soon. So has anybody got anything else I'd like to ask? If not, we can kind of wind down towards the end of the session. Oh, something's come up. Okay. From Rosie to everyone, thanks very much, Dave. Love hearing about zooplankton. She's on a SAMS course apparently. So Yeah, actually, just a little thought, actually, Dave. You know, like in the undergraduate degrees for marine biology, is there is there much kind of emphasis on plankton these days? I mean, do they spend a lot of time studying plankton and the role of plankton? You know,
The courses at laboratory.
I was thinking about some of the degree courses at the university.
University. Yeah, oh yeah.
Do you get involved in that?
I don't know, but they
Okay.
do. Yeah, they do quite a bit of sampling and studying it.
Yeah.
The students that we get in the lab, the MRes students, they get a talk on it. That's about all.
Okay.
They're really there to do their own project, and a very specific project. They get a bit of introduction to everything. That's all. But certainly at the university, they do, in the marine science courses, they do quite a bit of plankton, and we get people from Liverpool University coming down, and they get a bit of a course on it too while they're down here. And yeah.
Okay. All right. Looks like people are just sending in their thanks, which is great. So thank you everyone for supporting the Shores of South Devon. We have got some plans for next year, various projects we're thinking about, and we are going to be having some more Zoom talks. We're going to be having, hopefully, some live talks. And please keep checking out our Facebook page and our website. So the aim really is to go out on the shore and look at stuff. It's all rather wonderful. And as we've seen tonight, you know, if you do have the opportunity to go out and actually do a little plankton dip and then look in the Petri dish, it's absolutely incredible. Just a small dish of water, there's so much life in it. So it really is quite incredible experience looking at these small creatures. So thanks again, Dave. It's been absolutely brilliant. Yeah, really appreciate you supporting the Shores of South Devon. And thanks to everyone coming tonight. So
I'm always happy to give any talks to any sort of educational groups.
yeah, I know you are. Yeah, and thank you very much for that. Yeah,
it's part of the remit of the MBA. We've got this educational remit to do these sorts of things. And, so thanks much then, and enjoy doing that. All the best, everyone. Have a good Christmas. Cheers, then.